and welcome to this FortiWeb video on MCP protection. The Model Context Protocol, introduced by Anthropic and now adopted by many AI models, provides a standardized way for LLMs to interact with external services in a modular and dynamic manner. Before MCP, AI applications required developers to create custom connectors for each service and integrate them separately with every LLM. This led to duplicated effort, increased complexity, and inconsistent behavior across different models. With MCP, the protocol serves as a unified orchestration layer between LLMs and external servers. It standardizes how tools are described, how requests are made, and how results are returned, enabling LLMs to access diverse services through a single, consistent interface instead of many custom integrations. MCP brings major convenience and standardization, but it also expands the attack surface if not protected. In a typical AI application, the system integrates both an external LLM provider and a variety of internal resources such as databases, tools, microservices, and business logic to deliver end-to-end functionality. To support this architecture, the MCP server must act as an orchestrator that executes tools based on the LLM's tool calls and returns structured results back to the MCP client. However, because this communication channel allows the LLM and MCP server to dynamically invoke tools and access enterprise systems, attackers may attempt to abuse it in several ways. Common attacks towards the MCP-enabled AI systems includes the following types: prompt injection, tool poisoning. Attackers manipulate the LLM's input or internal prompt context to influence its behavior or force unintended tool executions. Supply chain attacks. These attacks exploit the dependencies and upstream components in the AI workflow. If the LLM provider is compromised, corrupted, or misconfigured, it may send harmful instructions that propagate into the tool orchestration layer. Architectural flaws. Security issues caused by design choices, misconfigurations, or improper isolation between components. For example, MCP servers accepting malformed or manipulated JSON RPC structures. FortiWeb provides MCP protection by inspecting and validating the SSE message between the MCP client and MCP server. It offers signature detection, poisoning attack scan, and JSON schema validation in its MCP protection feature. Signature detection scans tool argument values to block injection or command execution attacks targeting the MCP server. Let's look at an example where the attack succeeds without FortiWeb in place. A user submits a prompt containing malicious code in a parameter value that attempts to extract data from the user table. Because the request is not properly protected, the AI service responds with sensitive information from the database, such as usernames, email addresses, hashed passwords, and other private fields. To prevent this attack, enable signature detection within FortiWeb's MCP protection. This allows FortiWeb to identify and block malicious or unauthorized parameter values before they reach the application. Now let's submit the same malicious prompt again. This time, FortiWeb blocks the request when the LLM attempts to call the MCP server. The result shows that the system returned a web page blocked error message to the LLM. The attack is fully logged in FortiWeb, allowing you to review comprehensive details of the event. It's logged under the signature detection main type. In the log entry, you can examine the details such as exact attack payload and the parameter that triggered the violation. Poisoning attack scans help prevent threats such as malicious tool parameters that attempt to steal sensitive data, or poison tool descriptions and prompts that could mislead the LLM into performing unauthorized or dangerous actions. In this example, the prompt triggers the LLM to invoke a tool provided by the MCP server. Because the tool's description has been tampered with, it suggests actions that could harm the server. The MCP server still exposes this tool to the LLM, creating a potential risk where the LLM might carry out unsafe operations based on the poisoned metadata. Poisoning attacks can also occur when prompts are manipulated to trigger threats, such as parameter tampering or privilege escalation through hidden parameters. These attacks aim to determine whether the backend improperly trusts client-supplied values, potentially allowing unauthorized access or actions. For example, an attacker injects a parameter key to or history admin in the prompt to escalate privileges. As a result, the LLM sends a tool request to the MCP server with admin-level authority, causing internal data to be exposed in the response. To prevent this attack, enable poisoning attack protection within FortiWeb's MCP Protection. Let's run the same prompts after enabling poisoning attack protection on FortiWeb. This time, we submit the order query prompt to see what happens. The response indicates that the MCP server seems to be unavailable. This occurs because FortiWeb detects that the tool invoked by the LLM contains a malicious or tampered description that could lead to dangerous actions, and therefore blocks the LLM's request before it reaches the MCP server. Let's now submit the second prompt, the one containing the tampered parameter, and observe the result. This time, FortiWeb detects the malicious parameter in the tool invocation and returns a 500 error to the LLM, preventing the request from reaching the MCP server. You can view the attack log in FortiWeb. The category of the poisoning attack is under MCP violation. JSON schema validation ensures that MCP clients communicate using a valid, unmodified MCP protocol schema. After schema validation is enabled, FortiWeb blocks any LLM attempt to connect to the MCP server using an incompatible or outdated MCP schema. FortiWeb obtains the latest MCP schema through regular FortiGuard updates, ensuring it can always parse and validate the most current version. Violations triggered by schema validation are also logged, allowing you to review detailed information about each violation and understand why the request was blocked. To sum it up, FortiWeb provides the essential security layer that MCP-based AI applications require. Its advanced security engines block injection attempts through tool arguments, detect prompt and tool poisoning aimed at manipulating the LLM, and validate the MCP JSON schema to stop malformed or malicious requests before they reach the server. With these protections in place, organizations can confidently deploy MCP to orchestrate LLMs, tools, and back-end systems, without increasing their exposure to cyber risks. Thanks for watching.